Hi students. So in the continuing of water supply and wastewater engineering laboratory experiments, today we are going to see the other experiments. So before that, I am Dr. Prabhu, Associate Professor, Department of Civil Engineering, Kumar College of Engineering and Technology. So let us go with the experiment. So experiment number 11, determination of optimum coagulant dosage. So this is the experiment we are going to see. So let us start the experiment with the lab set in the lab setup. Yeah. So this is the optimum coagulant dosage method we are going to see. This is the flocculator. So based on the flocculation, so we are going to see the optimistic value of alum to reduce the turbidity in the water. So let us see in the setup. I have given in the flocculator setup. I have given the turbidity water, which has been characterized as a sample. I have a 4 sample of each 400 ml, and let us see about this flocculation machine. So here you can see this is the blade to flocculate that whole to agitate this wastewater. To agitate this wastewater, the flock is ready. So hence you can loose it here and make this blade, that is rotating blade for agitation, inner to this treatment. Let us have a small tight to it to make it tight. So in the same way, for each blade you can dip into it. So 50% of the water it has to submerge, and this blade should submerge to 50% of the water and fully thoroughly. So like that, in the evenly the blade should dip into the water, that is wastewater that has been collected from some waste. Okay. And so this is the setup we have to do. So collection of wastewater, and the wastewater has been taken evenly 400 ml, and this flocculator blade has been dipped into it and tight over here. And let us on the machine now. Right. So now we have on the machine. So before going to it, so you can add the alum solution measure the alum solution with measuring jar. So I am having to identify the optimistic alum solution. I am having different alum solution for a different waste. So let me add an alum of just 3 ml of alum I am adding here for the first waste, first sample, and for the second I am adding it as, for the third I am adding it as 9, and second I am measuring into around 6 ml of alum. So before using this, you make shake of this alum solution. And 9, and here I am taking around 10 plus 2, that is around 12 ml. So this is the alum solution. So hence, first of all, you can see what is the apparatus we have used here. So just a flocculator machine, okay, with the flocculating blade, and alum is our solution. So I have measured my alum solution different value, that is 3, 6, 9 and 12. Okay, right, now the machine is getting up ready, and hence we can leave this to flocculate for around 30 minutes, okay, 25 to 30 minutes, and allow to settle these particles down. So what happens is, when the alum you have it in this water sample, what happens is it makes charge of this particles to settle down very easily and reduce the specific gravity to settle down very easily. This is the process that alum will do. So whenever we get some water which has a turbidity, the turbidity can be reduced using adding of an alum. So here we are going to identify what is the optimistic value of an alum to reduce this waste, to settle down in the tank. Okay, so right, let me add, and I am keeping a speed of around 60 rpm per minute. Okay, so let us leave for 30 minutes to after 15 to 20 minutes, and you can off it and wait for settle down. So after 15 minutes of agitation, and this blade has been holded upstairs, and let us watch the settlement of all unwanted particles into the water down. So let me show you. So you can see the water unwanted particles has been deposited due to the coagulation process that is held, and you can see the difference in each and every bottle. So you can see how the water is very clear and the unwanted particles has been deposited in the tub. Okay, so first if the water was like this, and after adding of alum, you can check the clear water in the upstairs, and the unwanted matters get it down of below due to the low specific gravity. With adding with the alum, and it get it off down. So here we may have the three different type of alum we have added. Different ml of alum has been added here. One is 3 and one is about 6, 9 and 12. So this is the initial water. So already we know how to measure the turbidity. So the initial water can be used. Initial water can be taken as a sample 1, and which can be used to identify the initial turbidity of this particular water. And next, we can measure each and every turbidity for each and every water. So for example, this is the turbidity water, that is initial turbidity water. If it is nearly 10, so after adding alum, it may get off reduced to 1, 2 like that. So 1, 2, 3 or like that, so it may be added. So you can identify the efficiency based on which, right? Yes, in the optimum coagulant dose experiment. So this is the observation you need to do it. So this is the amount of alum we added. So what is the amount of alum we added for the different samples? It can be noted. For example, 2, 4, 6, 8 like that. And dosage is 10 milligram per liter, 20, 40 and 60 and 80. And you can identify the NTU values, that is from the turbidity meter. As we all know, we have seen the turbidity experiment previous. So in that you can see how to measure the turbidity. So this turbidity can be measured and the percentage of removal can be identified. And the initial turbidity of the given turbidity water sample can be noted here. For example, the initial turbidity is the sample which will be given to you, and that initial turbidity can be measured and written it in this here. And for adding of alum, we can identify the different NTU values for different alum dosage. And next, so after calculating of the efficiency, you can plot the graph between in X alum dosage and turbidity removal, and we can mark it and find the optimum coagulant. So that is 60 milligram per liter of alum can be added for 1 liter to get an highest efficiency for that particular wastewater. That can be identified from here. And thanks for watching the video, and thank you all.